Our next presenter obviously had an introduction a little bit earlier, needs no further introduction. Rory?
So before I start, I'm presenting here my previous presentation, this presentation, on behalf of the University of Northampton, where I'm a visiting professor. I just wanted to clarify maybe some misunderstandings about the retirement of Professor Kaczmarczyk. He's retiring sort of the way I retired, which is kind of like not retiring. And so he's still going to be my boss for the university issues. He's still going to be managing the MSc program and participating in the Lift and Escalator Symposium. What he's come up with is a clever scheme to get out of all of the paperwork nonsense and bureaucracy. So congratulations on doing that, but he's still going to be around. So just want to clarify that. So talk about Bowtie diagrams. About a year ago, Professor Kaczmarczyk came to me and said, well, we have to do a proposal, the university does, on some risk assessments, and they want us to use Bowtie diagrams. So, well, what's a Bowtie diagram? I'd never heard of a Bowtie diagram before. And so I had to learn about them, and I got actually involved with our client. I found they're really an interesting thing, and they offer a lot of assistance in risk assessment processes. So I'm going to talk a little bit about, in more depth than I did previously, to risk assessment, which may be boring and repetitive for those of you that are very familiar with it, but I just wanted to explain the differences and how I think the Bowtie diagrams can augment and improve the standard risk assessment methods for lifts and escalators. So again, safety is the freedom from unacceptable risk. And safety is achieved by risk assessment, risk reduction, and I'm going to go through these important definitions one last time here. Hazard is potential source of harm. Harm can be damage to people, but it can also be damage to property and damage to the environment. And when we're conducting a risk assessment, we need to look at all three of those. You think about, well, how do we damage the environment? We do a lot of hydraulic lifts, and the hydraulic fluid gets away, that's environmental damage. And there's other things we can do that can be damaging. So, and then risk is a combination of the probability of the occurrence of harm and the severity of harm. And when you're doing a formal risk assessment, you end up using the method, the method that's recommended in the ISO standard, you end up quantifying both of these and come up with a matrix that quantifies them. So this is the matrix or the table for probability of occurrence. And you see something that's highly probable is likely to happen frequently in the life cycle. And it's the life cycle of the lift or escalator, which can be 40 years, or for a disposable lift, maybe 8 years. So it's a short life cycle. Then it's probable, well, it's likely to happen several times. You can see there's occasional, remote, improbable, and highly improbable, meaning it probably will never happen. And that was where I used the example of being struck by a meteor. Could happen, but doesn't happen very often. So then we have the severity of harm. A high severity is where you're gonna basically kill somebody or severely injure them and do environmental damage. Medium is severe injury, but probably not death. Low is a minor injury, and then negligible is something it doesn't even have to be reported. So there's a combination of these two, and so the risk is estimated this way. Shading is not easy to see here, but these areas here are gray, and these are combinations that you have to do something about. There's another section here that's very light gray where you may have to do additional assessment, and you have to consider what's practical and also what's socially acceptable. So we accept risks, and we don't accept risks at the same level. For instance, we always have hoistway doors on lifts, but we don't always have the equivalent of hoistway doors on underground systems or trains. Now, you see a few underground stations in London where you actually do have the equivalent of hoistway doors where you can't fall under the tracks unless, but most of the time you can fall under the tracks and get run over on a train. So we accept that risk. And so with lifts, we're less risk tolerant than we are in other industries. I did that again. So we do a risk evaluation, and you come up with all of these combinations. The first category was the top ones, Protective measures are required to reduce the risks. The middle level is review is required to determine whether any further protective measure is appropriate and it meets societal values. And if you get into this third category, you don't have to do anything. It's a safe system. So, and then you fill out this table here, and you look at the hazardous situation, the cause, the effect, and you look at the estimation of the risk. Then you look at what protective measures you're going to put in, and then you look at how that changes. And all of this is defined in, again, this is ISO document. It's a quantitative method because it returns an alphanumeric risk value. So it quantifies the risk, makes it easy to look at. So let's take a look at a sample risk assessment for, in this case, an escalator. So you see here a nice clean escalator. You can see all of the tracks. You can see the steps returning, and it happens to be very clean. But this is kind of the exception, and a lot of times they end up looking like this, and where you have a big collection of grease, dust, newspapers, and this can actually turn into a very hazardous situation. And there was a good example here, King's Cross in November of '87, where it caught fire, and a lot of people died. And it did involve an escalator like this, where you had wooden step treads and wooden balustrades. Still a few of these around. This one happens to be, I believe it's Macy's department store in New York, and it's still running that way. It's almost an amusement ride because everyone wants to try it out. But underneath it all, it's still mostly steel. And here's what was left of King's Cross. And so I think something like 50 people were killed. So let's take a look at how we would handle that, how we would handle the risk assessment of fire on an escalator. This is very simplified form. But here we look at there's a fire risk. There's an accumulation of flammable material. The effect is it catches fire and burns and people die. So that's a severity of high severity. And C, occasional probability. It doesn't happen all the time. So what can we do to mitigate it? Well, regular cleaning. But the severity doesn't change. But the probability of occurrence shifts to a D, remote. Still, you have to do something extra about it. And I think some escalators never get cleaned, or very rarely. I think the London Underground is weekly. They want them cleaned because they had a bad experience. And so, we'll go back here. So we look through these again, and let's take a look at if we do one other thing. Now we're going to install a fire suppression system. So we can't keep it from happening, but we can do something to limit the severity of the damage. So we'll put a fire suppression system under the truss, and now we go to a 1F, where it's highly improbable that anyone will be injured, because we're going to try to keep it clean. But if we fail to do that for some reason, or it still catches fire, with a fire suppression system, we can stop it from happening. This is a typical simplified system, and that's where Bowtie diagrams come in. And Bowtie diagrams actually came about as a result of a fire on an offshore oil rig in 1988. And they'd existed, but it was a Royal Dutch Shell platform. And they adopted Bowtie diagrams as a way to analyze what happened, and how to use that in the future to assess potential risks. It's a little different because it's a graphical system. This is a simplified Bowtie diagram, but it's a generic diagram that's available from a company called Bowtie Master. You can get it on the internet. I'm not advertising for anybody, but these are just simple things. You can get this one on the line. You can play with it. I think they sell software. And so if we take a look at this, why do they call this a bow tie diagram? Well, because it sort of looks like a bow tie. And that's why they're called bow tie diagrams. So, okay, it's a bow tie diagram. And you have something here called the top event. This is where you lose control of the situation and the accident actually occurs. There's two sides of this. One side is the preventive side, here we're trying to keep it from ever getting to this point. And here, if we lose control, what are we going to do to keep it from getting worse, or to limit the amount of damage? We'll use the same example, but this is a simplified form. This is a very complicated one, and this is by a company called Bowtie XP, who 75% of the people using Bowties use this software. It's a required software by the Civil Aviation Authority here in the UK, by the Railroad Safety Administration. Anything on rails, they're going to use this. And I think it's a really good system. You have both sides here. This is lifting operations and having something fall. They have all of these are potential problems that result in this, and here's what they can do to keep it from, here's what you can do. These barriers keep it from happening, and these barriers keep it from minimizing the harm. So it's a very useful thing, but it is a graphic tool. It's not quantitative necessarily. It's qualitative. So let's take a look at fire on an escalator. And so we have an accumulation of flammable materials. And over here we have the mitigative, there's no barrier shown here yet. This is the consequences are death or severe burn injuries. So we'll use the same thing we did with using the ISO standard. We'll say, well, okay, we're going to schedule cleaning of the truss and pits, and then if that isn't good enough, we're going to do fire suppression system on this side. But they add one other really interesting concept here, and it's called an escalation. Now, normally when I think of escalation, it's because someone's not doing their job and I have to go to their boss. But in this case, it's what happens if you fail to clean on schedule? Well, if you fail to clean on schedule, you basically eliminate this. So this shows you what can go wrong over here that changes degrades your preventive barrier. I think it's a very interesting concept to look at because things like this don't happen. What if you don't do maintenance on anything? This new IoT and everything, which I really love, you still have to do the basic oiling, greasing, and cleaning. And that seems to be forgotten. And with escalators, you really need to do the cleaning. So, but here we put the fire suppression system in. And you can see that, okay, here, on this side we're preventing, on this side we're mitigating. And this can be useful not just to the people doing the risk assessment. Risk assessment is done by a team. So you get multiple opinions, and you have to have a moderator. But it allows people to visualize better what they're doing. It also allows you to show this to whoever's going to use the system when you're all done, to explain to them how the system works and why it's important. So it's a tool. So the risk assessment still ends up looking like this, where you have, this is the quantitative, because we come back, we go from 1C to 1F after we take the two mitigating items. And here we have the qualitative, where we have the graphic representation. So it's a combination of the two, and that's why I think they're very valuable. So the project I was in, it really helped us understand what things were, and it facilitated the discussion of what risk we were taking a look at. So a Bowtie diagram is a qualitative method. It returns a graphic representation of the risk. So the conclusions are, the standard is a proven quantitative risk assessment method, but Bowtie diagrams are a useful tool that helps the risk assessment team to visualize the hazard, the risk, the mitigation. Questions?
Any questions? Yes, Adam.
Thanks, Rory. Thought-provoking as always. It's an observation, really, rather than a question. But, of course, I also recall the other big change that came out of King's Cross was we stopped people smoking on the underground. So, yes. Which presumably then affects the occurrence probability, not the severity.
Yes, the severity never changes, but it reduces the other probability. But there's other sources of ignition. So it could be electrical, it could be people not doing what they're supposed to be doing, forgetting to put out their cigarettes before they get on the escalator. And yes, that not smoking has a lot of other benefits too, not just that.
Any other questions? Anything further from the floor?
Very good diagram. What happens where you had that situation where the maintenance wasn't happening? You seem to take the arrow back into where the actual still mitigating circumstance, but in actual fact it wasn't.
Well, I think that's why Lift Consulting is a growth industry. So, one of the things you have to consider in the UK, there is no supervision of any of these codes. There's no enforcement agency, so it's voluntary compliance. Other parts of the world, there's police that monitor things and inspect. So it's something to consider. What's happening here is if it's voluntary compliance, some people will voluntarily do the right thing and others will not.
Sure. Any further questions? Can you just pass that down?
I think I'm probably loud enough. I can manage without that. Okay. My name is Matthews. I come from India. Great to be here. I mean, the first set of presentations, I'm glad to know that some of the problems that we have, you also share with it.
Right.
I've been now 35 years, not as long as you in the industry, and I sort of see a trend where we create a risk and then come with a mitigation activity. Like, let's say, for instance, look at the escalator. Mm-hmm. We don't do the maintenance because of no time or whatever it is. And then we say that, okay, as a mitigation thing is a fire suppressant. Now, who's going to maintain that? Who's going to check that? We come up with an MRL which requires a rescue device. We come up with a battery. Mm-hmm. And now we have a mitigation to check the battery. Mm-hmm. Where's it going to end?
Well, I guess the better question is how do we keep this from happening in the first place? So the idea of I worked for 5 years in the Middle East, and every lift there had to have a battery rescue device that would actually move it down the floor. None of the batteries worked. None of them would have worked if there were a power failure, because there was no real standard to monitor these or to do something. I think monitoring the batteries is a really good idea. And I think the incidence of bad batteries is underreported. You have good paying customers. You don't have there's a lot of people with no maintenance, no inspection, and I'll bet you there's a lot more bad batteries. And 50 years ago, one of the things I did in my spare time was repair emergency lighting units because they were required in the U.S. and none of them worked. So it's something that we need to build this in right from the beginning. And now we can do it. We have monitoring that's really good. And it can be done.
Incidentally, the modification of ISO 8100 Part 1 for India, we've actually put battery monitoring as a compulsory requirement.
Well, that's good.
OEMs are pushing back, but then I think it's a necessity.
Well, they shouldn't push back because basically it's a cost that you build into your maintenance, and you perform the maintenance, and you have to look at being ethical and responsible and check the things, make sure they're there when you need them. So, yeah.
I'll just make the observation there, Rory, that using, if you like, diagrams to illustrate risk rather than alphanumeric symbols is far more impactful. Yeah. You do take recognition of that. It's a bit like street signs, isn't it? They're graphic rather than written. So they do have an impact. So that approach is obviously one that's really interesting, I think, and one that has got a lot of mileage.
Yeah, and that's why I kind of got to really like them after getting over the shock of having to work with them. I thought, this is pretty good. I'd like to share it with everybody because it's a good system.
Okay, thank you very much. Thanks, Rory.
Thank you.
For that.